Today we're going to take a look at some scale drawings and some dilations, and we're going to get some basic vocab words that we're going to be using throughout this unit, as well as looking at some different constructions. So a big vocab word that we're going to be using is something called a scale factor. So a scale factor, we could look at this maybe two different ways. First, I could say it's a number which multiplies or we could say scales a quantity. So the key word there is multiply. So we will be using that as we're doing dilations. Our process, our calculation will be multiplying. Another way that we could take a look at this is it's going to be a ratio of two corresponding lengths in two similar geometric figures. So when we're looking at this, we will use our second kind of definition a little bit more to compare and see if figures are in fact similar. So by comparing, getting that ratio. And the scale factor, thinking of it in terms of multiplying, we're going to probably use it a little bit more when we connect that to the word dilation. So scale factor, sometimes you'll see it as the symbol R. A lot of times you'll see it as the symbol K. So when we see that value, or when they give us that scale factor, and we see that scale factor is greater than 1, we can say an enlargement has happened, or a growth, or I can see the picture has gotten bigger. When I see that value, the scale factor, again, could be R, could be K, they could just say the scale factor, is between the numbers 0 and 1, then we can see a shrink or a reduction has happened. So it's going to get smaller. So if it's greater than 1, it gets bigger. If it's between 0 and 1, it's getting smaller. And we're going to try and do a construction. So we do need a compass. And what we're going to do is we're going to actually try and create this scale drawing. And you can see it says it has a factor of 2. Meaning it's larger than 1, it should be getting bigger. So at the end of this picture, I should be seeing a larger picture of triangle ABC. Now it doesn't tell us where to do this, how to do this, where we need to put our point. I'm going to say, let's consider, just for the ease, A is going to be our center. So if that's going to be the case, first thing we want to do is take these sides, A is our center, and we're going to extend them out. So you should do this with a nice straight edge. And then your next step is we're going to just do the basic copy a segment construction. So you put your sharp point at A, open up your compass as wide as B, and then in order to copy the segment, you just make a mark so that shows that you have copied it. It's the same size. Pick your compass up, move it over, and now you're going to do the same thing one more time. It says a scale factor of 2, so the first mark I made would be a scale factor of 1. Scale factor of 2, there's my second mark. So what we've just found now is our location for B prime. Okay, and now we're going to do the same thing, but over here for AC. So again, we're copying the segment. So I need to make my compass as wide as AC. And once I get it to be as big as AC, I want to make a mark showing that I've measured it. So that would be scale factor 1. And if I move it one more time, scale factor 2. And so over here, we've now found C prime. And if I were to finish this triangle off with a nice straight edge, I would connect C prime to B prime, and now I can see comparing the initial figure with our scaled figure. Our scaled figure is much larger. And again, it should be. Our scale factor was 2. It was greater than 1, so we said it would be an enlargement. Now, true about this, the sides of the scale drawing. So not only are they larger, but we can also say all sides are in proportion. connecting it to that idea, that definition that we had up above with the ratio. So I can say they're all going to be in the same proportion. In this case, comparing the big triangle to the small triangle, we could say it would be in a 2-to-1 proportion. So you could see it as like a ratio, 2-to-1 proportion, big to small. What is true about the angles? Well, I can tell you your angles are all going to be congruent. All angles are congruent. They're never going to change. And I can see that probably most visibly with angle A. A didn't change. But if I take a look at B prime and B, those should look like corresponding angles, and that's because they will be. So I know then a couple other things we can pull from this. If these angles are congruent and they're considered corresponding, that's also going to tell us if these lines are parallel. And I could do the same thing for the angles at C. On the bottom, it's saying, okay, so if somewhere else on our paper we did the same exact thing, same exact scale drawing, kept the scale factor of 2, but we started it at a different angle. So maybe we did the same construction at B. Would the drawing still be a scale drawing? And that answer is heck yeah. As long as we kept that ratio at 2 and we did the same process, it does not matter where you start from. So you could start at B, you could start at C, you will always have a scale drawing. Now on the back, what if we already have the scale drawing? And it says we're going to use our ruler to find the center of this scale drawing. So it says use your ruler, determine the location of the center. So what are we going to do? Well, we're going to connect the dots. That's all this really is. With a nice straight edge using your ruler, if you connect A prime to A and extend it out. And then we're going to do the same thing with C prime to C and extend it out. And we're going to do the same thing with B prime to B and extend it out. And what I'm noticing is that all of these lines start to intersect at one location right there. So what you have just found, it said we're looking for the center of dilation, or the center of our transformation for the scale drawing. This is your center. So then the question, would the scale factor be greater than 1 or less than 1, and why? Well, our pre-image looks to be smaller than the image. So if our picture has gotten larger, that means the scale factor has to be greater than 1. So I can say K, or R, has to be greater than 1, because I can say triangle A prime, B prime, C prime is an enlargement. Okay. We're going to take a look at doing another scale drawing. So again, we're going to need our compass. And a little bit different this time. We have just a segment. And it says the image below, point C is lying on segment RS. And we're going to use our compass to help determine, or to help dilate, I should say, segment RS with a scale factor of 1/2. So now if I'm thinking what that scale factor means, 1/2 means I have to make it smaller. And it's also telling me C is my center point. So I'm going to take a look at this and say what we need to do is go from R to C, and R has to be 1/2 that distance away from C. In other words, I want to think bisect that segment RC. So we're going to go back to that basic bisect a segment construction. So sharp point at R, we're going to put our drawing point. It has to be at least more than halfway. So if it makes it to C, great. If it doesn't, that's okay too. And from here, what we're going to do is make an arc. Top and bottom, and then flip it around. I'm going to go over here to point C, top and bottom. And now what we have found here, if I were to connect this with a nice straight line, is that point of intersection. And that point is now showing us where our new R prime is going to be located. Now we have to do this again on the other side for segment CS. So again, I want to think bisect the segment. I want to think make it more than halfway. It could go all the way to C, doesn't have to. We're going to do arc on top and bottom. I'm going to flip it around. Again, we're going to move it back to point C because that's the segment that we're cutting in half. Arc on top and bottom. And then with our straight edge, we're going to connect this one. And again, what have we found? We found now that is point S prime. So if I now connect R prime to S prime, what I notice is that that segment RS has been dilated, has been shrunk, and the scale factor is 1/2, meaning it is half as big. And we said if our scale factor was in between 0 and 1, it should get smaller, and our picture did in fact get smaller. So quick summary, we've kind of talked about this a lot. What happens when the scale factor is less than 1, and keep in mind greater than 0, we can say a shrink or a reduction in size. What happens when the scale factor is greater than 1? We have an enlargement. Or you could say again, it's gotten larger, it's gotten bigger. So what happens if the scale factor is equal to 1? Well, when we did our first construction, when we made those marks on the triangle, our first mark was a value of 1, and it didn't change the size. So if the scale factor is equal to 1, it would remain the same. And we're going to say same size. So it's not going to change. Okay. One thing we haven't talked about is, well, what if it's a negative? All right. Well, scale factor should always be positive. It's positive because we're thinking about distance. Distance is always positive. So a negative distance would not really make any sense, so therefore you're not going to have a negative scale factor. That's why we have that restriction between 0 and 1. So what we're noticing here is the scale factor is starting to be connected to that concept of dilation, meaning something's getting bigger or smaller. So when we have a dilation, we can take a look. We get two big properties. And the first property that we have is the segment that we have transformed. Notice what this is saying. It's saying I'm going to take my scale factor and multiply it by that original segment that we have. So our segment over here, A prime, B prime, is going to be the length of whatever that original segment AB was times the scale factor. And then the other thing we also talked about is that they will always be parallel. So again, we said in that first problem that these two angles were congruent because they were corresponding. Well, they have to be because these two lines are going to be parallel. Right? When two figures have sides that are in proportion and angles that are congruent, we can say that they are similar. So we're seeing this concept of similar figures and dilations, they are being connected. Okay. And then a technical definition, just so that we know maybe what's going on in our technical notation. A dilation really is just to make a shape or a figure either larger or smaller. Okay. And our notation. So for dilation, we're going to have a capital D, and then you get a little number underneath. That's that scale factor. And it'll be, let's say, for instance, on a coordinate plane, you're going to maybe get this coordinate. So what happens here? So all that's saying is you would take that coordinate, multiply it by the scale factor for the x, do the same thing for the y. Take the coordinate, multiply it by the scale factor, and now you'd have your new location. So that's a quick overview of similar figures, dilations. We're going to do much more with the compass in class, and then we're going to progress on to coordinates and see how the calculations would work. Don't forget to like and subscribe, and I hope this helped. Have a wonderful day.